Well, I just checked my phone, and apparently the temperature outside is around 80 degrees Fahrenheit, which is nice, but it's hard to forget Minnesota's winters. But thanks to those heating systems that we have on top of our ME building, we don't need to wear jacket inside. It was reported that around 17% of the US energy is consumed in heating, cooling, and air conditioning systems. And we want these systems to be as efficient as possible. One of the core components in these systems is electric motor, which is something that my research is targeting. Almost in any electric motor system, there is a rod in the middle that spins. And it's the thing that drives our electric car and electric bikes. But we need something to hold that rod in the middle. And for that, we usually use two mechanical components called bearings. These bearings are responsible for supporting that rod and prevent it from moving around. But because these bearings are in contact with that rod, they're usually a source of friction in the system. You can imagine if you hold the bat in your hand and you try to spin it, after a while, you can feel your hands are getting warm. And this is actually because of that friction that we don't want in our system. In conventional electric motor systems, a magnetic field is used to spin that rod. But the topic of my research is to manipulate that magnetic field to rotate that rod while it's magnetically levitated. And because it's levitated, then we don't need those bearings. This technology is called bearingless motor. And the basic concept behind that is when you try to push two magnets together when the same poles are facing. Bearingless motors are great. Because they don't have bearings, the whole system is more compact, and there's no component to wear out in high speeds, and they don't need lubrications. But so far, this technology has only been commercially implemented in small applications like artificial hearts or small pumps. And in my research, I'm trying to overcome the challenges of implementing this technology in industrial level applications that we're dealing with very high forces. For example, those heating and cooling systems. Thank you.